Hi, I am Dr. P and welcome to the first video of our calc course, right? So in this video, we are going to kind of get you introduced to the very first lesson. The very first lesson is actually it's on the velocity problem. The velocity problem is a fundamental problem. It actually taps into a very fundamental idea of calculus. So let's understand this through an example. Suppose a ball is dropped from the desk on the deck of a tower, which is 450 meters above the ground. So we have a tower, right? Okay, and from the top of the tower, right? Okay, we are dropping a ball, and the ball is going to fall under gravity, and this is 450 meters above the ground. And they want you to find the velocity after 5 seconds. Now, usually you may have seen what's the big deal here. See, before calculus, you may have done problems like this, okay, where you find the velocity as the change of distance over the change of time. Change of time. In all these problems you have done before, they would have asked you to find the velocity between, say, 5 and 6 seconds or 5 and 7 seconds. But in this example, they want you to find the velocity after exactly 5 seconds, instant velocity, which is an interesting problem because if the velocity is change of distance over change of time, if you want it exactly at 5 seconds, then there is no change of time. So then the denominator becomes 0. So we can see at the denominator, this becomes 0. We are dividing by 0, which is a problem. Okay, so then how exactly are we going to find the velocity exactly after 5 seconds? This is a central problem which introduces you to the concept of limit. If you may have heard Isaac Newton's discovery of gravity, by the Apple, he had the same sort of idea. He's the one who invented this concept of limit. All right, so what we're going to do is, first of all, we are going to use a result from physics, which says is that if something is traveling under gravity, the distance after t seconds of an object is given by 4.9 t squared. Okay, so let's use that formula from physics. So that means that if you want to find the distance after 10 seconds, you just plug in 10 here. If you want to find the distance after 5 seconds, you just plug in 5 here. Distance only. Okay. Now, let's again review a concept that you have done before, average velocity. Average velocity is what? That we have done for your basic math. It's a change of distance over change of time. Now, suppose we want to really find the velocity at 5. But instead of doing that, let's try to find the velocity between 5 and 5.1. Why are we going to do that? Because, well, we need it to move a little bit at least if you want to find the average velocity, because there has to be a change of time. But if you make that change of time small enough, you would expect you to get a better result. Instead of going from 5 to 10 seconds, might as well go from 5 to 5.1 seconds because it's a smaller gap and see what happens. So remember, we are now finding the average velocity, not the instant velocity. We are letting it move from 5 to 5 seconds, 5.1 seconds. All right, so how do you find the average velocity? First of all, you need to find the distance, change of distance. So you need to find the distance at 5.1 and subtract it from the distance at 5. So how do you find the distance at 5.1 seconds? You just go up here and plug in t equals 5.1. So you just get 4.9 and 5.1 squared. And this is the distance after 5.1. And how do you find the distance after 5? Well, you go up here again and plug in 5. This is the distance after 5. This is the distance after 5.1. This is the distance after 5. So their difference is the change of distance. So this is the change of distance. And what is the change of time? The change of time, of course, because we are going from 5 to 5.1, the change of time will be just 0.1, right? Okay, zero point 0.1. So this is the change of distance. You're dividing by the point 0.1. And if you use your calculators and work this out, you will get 49.49 meters per second. Now, is that accurate? Well, you might say, well, the distance between 5 and 5.1 is very small, so this may be accurate. But the reality is that a lot of things can happen in that zero point 0.1 second. Really, it may be a zero point 0.1 second for us, but lots of things can happen. All right. So let's try to see whether there is a way that we can improve this. So what this result? So first of all, if you look at this chart, I have actually found the average velocity for different intervals. So between 5 and 6, it's 53.9. Between 5.5 5 and 5.1, we already got this 49.49. And if you use a similar technique, but if you use the distance gap to be even smaller to 0.05, then it's 49.245. And then if you go from 5 to 5.01, even smaller, then you get 49.049. And if you go from 5 to 5.001, even smaller, but now we are looking at a really small gap. The distance, the velocity, average velocity between 5 and 5.001, that is 49.0009. So if you look at this, right, you will see that as the gap becomes smaller and smaller, the time gap becomes smaller and smaller, the average velocity seems to be heading towards something. And you can see that actual something is 49. Now the good question is, will it ever hit 49 in this case? Well, it doesn't really touch 49. At the same time, the time interval is getting smaller and smaller and smaller, but the time interval can never be zero for the average velocity because then you're dividing by zero. But you can say that if you take the time gap, right, and so what you do is you take the small time gap, and you limit that gap to zero. That's the idea of the limit. You want to make this gap, the time gap, okay, go to zero. Okay, so you want to make that to you. So how do you represent that mathematically? So what you're going to put is, remember how we found this, right? We calculate, we have the function s, okay, that is this function that we saw before. What we did was, remember again, we put in 5.1 to that function, subtracted 5, we put 5 to that function, so s of 5.1, so this can be written as s of 5.1 minus s of 5, and you divide by the gap, which is 0.1. So we can actually write it in another way if you want. You can put s of, I'm sorry, so it was, so if you remember what we did here, this was actually s of 5.1, okay, because we put 5.1 for t. And if you look at this, that was s of 5, and we divided by 0.1. So we can do it for a small change of time. So what you do is, we can, instead of putting 5.1, we can put 5 plus a small change. So it is a small change of time minus the original time 5. So this will be the distance at time 5 plus h. This will be the distance at 5. This will be the change of distance, right? And you divide by the time gap. And what's the time gap? Well, it's 5 plus h and 5. So the time gap is h. Okay, so this is the time gap. And we showed that if you take the limit of this as the time gas goes to 0, okay, we got 49. Okay, as we saw from the chart that you showed there, right? Because this was heading towards 49 when the time gap actually becomes smaller and smaller. So this is the idea of a limit. And We will learn later that this velocity that we found at 5 seconds is called the instant velocity. So the idea of a limit is there. The idea of a instant velocity is there because it is no longer the velocity at 5.1 or 5 between 5 and 5.1 or between 5 and 5.2 or anything. This is the velocity at 5. And how do you find it once again? You consider the distance at 5 plus h, a small change in time. Subtract the distance at 5, so that is the change of distance, divided by the change of time, which is just h. So, and we send that change of time to 0, the limit. It never really becomes 0, it's only touching 0. It's not touching 0, it's coming very close to 0. This average velocity heads towards 49. This is the idea of limit. So we'll talk more about it in class, but this is just an introduction. Thank you for watching.